So chapter 4.7 is dividing polynomials. So far we've done adding, subtracting, and multiplying polynomials. So now we'll do dividing. So before we get into the more difficult ones, we'll start by dividing a polynomial by a monomial. So a monomial being one term. And to do this, we're going to recall how to add and subtract fractions. So when we're adding fractions with common denominators, we just add or subtract those numerators and put it over that common denominator. We're going to think of this in the reverse direction, and it'll tell us how we're going to be dividing polynomial by a monomial. So we're going to start with multiple terms in the numerator, all divided by a monomial. We're going to split up the fraction and give each term in the numerator its own denominator, which is the monomial. So let's see examples of this. So the first one, we have 2 plus 5 over 3. So obviously this is 7 over 3, but that's not the way that we're doing this. I just use numbers to show it. So what we're going to do is give each term in the numerator that denominator of 3. So it's going to be 2 over 3 plus 5 over 3. Okay, so as simple as that. This one can't be reduced or anything, so we'll just leave it like that. So now let's get into the actual one. So 12x squared plus 6x, all divided by 6x. So we're going to split up the fraction, 12x squared over the denominator plus 6x over the denominator. So for the first term, 12 over 6 is 2. X squared divided by x is x, so that's 2x. Plus the second term, 6x over 6x, is just 1. So it's 2x plus 1. Okay, next one, we have 5m to the 5th minus 10m cubed all over 5m squared. So we're going to split it up once again, 5m to the 5th over 5m squared minus 10m cubed over 5m squared. So that first term, 5 divided by 5 is 1. They cancel. M to the 5th over m to the 2nd. That gives us m cubed. 10 over, for the next term, 10 over 5 is 2. M cubed over m squared is just going to give us m. So we have to remember our exponent rule as we're subtracting those exponents. Okay, and the next one, we have 16a to the 5th minus 12a to the 4th plus 8a squared all over 4a cubed. So we're going to give that denominator to all 3 terms in the numerator, and it'll look like this. So now we need to simplify each one separately. So for the first term, 16 over 4 is 4. A to the 5th over a cubed, subtract those exponents, we get a squared. Minus next term, 12 over 4 is 3. A to the 4th over a cubed, subtract the exponents, it leaves us with a. Last term, 8 over 4 gives us 2. A squared over a cubed, that's going to end up leaving an a in the denominator. If we subtracted the exponents, we'd get a to the negative 1, which means we have to put it in the denominator to make the exponent a positive 1. Okay, so let's do one more before we make them a little bit harder here. So we have those 3 terms in the numerator divided by negative 4x. So we have to give all of those terms in the numerator negative 4x as a denominator. And we end up with that. So simplifying these step by step. First term, negative over a negative becomes a positive. We're going to get 7 over 4. X cubed divided by x gives us x squared. So I'm going to write it like that. So that's 7/4 times x squared. Next is going to be negative because 12 divided by negative 4 is negative 3. So minus 3. X to the 4th over x is x cubed. And then lastly, for the last one here, negative, we're dividing positive by a negative, but we were subtracting, so it ends up being a positive. So it's going to be 4x over 4x, which is 1. So 7/4 x squared minus 3x cubed plus 1. Okay, so now the questions will be getting a little bit harder, but before we get there, we have to mention what the division algorithm is. So when we're dividing two numbers and we have numerator divided by denominator, another word for the numerator is the dividend, and another name for the denominator is the divisor. When we divide things, the answer is the quotient. But sometimes we have a remainder, so the way we have to write it is plus the remainder over that original divisor. So this is called the division algorithm when it's set up like this. We actually kind of know this because that's how we create mixed numbers with fractions from improper fractions. So let's see an example. Let's say we have 37 over 5, and let's say we wanted to divide that. So 5 goes into 37 7 times. We multiply, we subtract, and we get 2. So labeling everything here, the 7 is the quotient. The 37, which was the numerator, is the dividend. The 5, which was the denominator, is the divisor. And the 2 is the remainder. So if we write this in the form of that division algorithm up here, it's going to be the original problem, so 37 over 5, equals the quotient, which is 7, plus the remainder over the divisor. So that would be our answer using the division algorithm. As a mixed number, we would say 37 over 5 is just 7 2/5. Okay, so we're going to be doing the same thing but with polynomials, but it'll seem a little bit more challenging. So now doing long division for polynomials, what we're going to do is start by dividing the highest degree. So we're going to look at the largest the term with the largest exponent, the leading term, on both of the polynomials, and we're going to divide them. And that's going to be what goes in the quotient. And then we're going to do it the same way we did it when dividing numbers. We're going to multiply that through the divisor and then subtract and then essentially start over. We're going to keep doing this and then until the degree of the remainder is less than the degree of the divisor. And when we're setting these up using long division, we have to make sure each polynomial is in standard form, which is descending order for the exponents. And if the dividend or the divisor, I'm going to add that in here, if they're missing a term, we're going to write in the term using a 0 as the coefficient. So we'll see why. I'll mention that again once we get there. And then we're going to write each answer in the form of the division algorithm. So let's do this example. So we're going to divide x squared plus 10x plus 21 over x plus 3. So setting this up, x squared plus 10x plus 21 divided by x plus 3. So what we have to do is go to the leading term of each one and divide it. So dividend first, so x squared over x. X squared is the leading term in the dividend, and the x is the leading term in the divisor. So we get x. So that's going to be what goes in the quotient. Then we have to multiply the x by the divisor, x plus 3. So x times x plus 3 is x squared plus 3x. And we have to remember that we're subtracting it. So the x squareds cancel, which always should happen. 10x minus 3x, we're subtracting down the column. 10x minus 3x is 7x. And we bring down what we didn't use, and then we do it again. So 7x is the new leading term, divided by still the leading term in the divisor, which is x. So we get 7. So it's going to be plus 7. We have to multiply the 7 by the divisor now. So 7 times x plus 3 is 7x plus 21. And the 7x's cancel, and we get 21 minus 21. That actually gives us a remainder of 0. So writing this using the division algorithm, it'd be x squared plus 10x plus 21 over x plus 3. That's going to equal the quotient plus the remainder over the divisor. So since that remainder is 0, we don't need to write that in. So I'm just going to write it as the original problem that we just did equals x plus 7. Okay, so that's our answer for our first one. So let's do ones that get a little bit harder where we don't have a remainder of 0. So 4 minus 5x minus x squared plus 6x cubed divided by 3x minus 2. So setting up this dividend, we have to put it in the correct order in standard form. So 6x cubed minus x squared minus 5x plus 4. And that's going to be divided by 3x minus 2. Okay, so same idea as what we just did. We're going to divide the leading terms. So 6x cubed divided by 3x gives us 2x squared. So that's going to be our first part of the quotient. We have to take that and multiply it through the divisor. 2x squared times 3x minus 2 gives us 6x cubed minus 4x squared. And we have to subtract it. First terms cancel. Negative x squared minus negative 4x squared. That's negative 1 plus 4, which is 3x squared. Bring down the other stuff. And then start it over. So now 3x squared is the leading term. Divided by 3x, that gives us x. So that's going to be plus x. Multiply x by 3x minus 2. We get 3x squared minus 2x. Subtract it. Those first ones cancel. Negative 5 minus negative 2, that's negative 5 plus 2, which is negative 3x. Bring down that 4. And we can go one more time here. It's going to be the leading term of negative 3x divided by 3x. We get negative 1. So minus 1. Multiply negative 1 by 3x minus 2. So we get negative 3x plus 2. We subtract it. Those cancel. We get 4 minus 2, which is a remainder of 2. Okay, so setting this up using the division algorithm, it's going to be 6x cubed minus x squared minus 5x plus 4 over 3x minus 2. It's going to equal the quotient, which is 2x squared plus x minus 1, plus the remainder over the original divisor. And that would be our final answer using the division algorithm. So writing out this dividend here for dividing these two polynomials, we have 6x to the 4th plus 5x cubed. It's missing the square term, so I'm going to put in a 0x squared and then plus 3x minus 5. So putting in the 0 coefficient just makes that whole term 0. And then 3x squared minus 2x. So dividing these leading terms, 6x to the 4th divided by 3x squared gives us 2x squared. So I'm going to put that above the 0x squared to have it lined up. So multiplying 2x squared by the divisor, we get 6x to the 4th minus 4x cubed, and we have to subtract it. So the first one's cancel, and then 5 minus a negative 4 is 5 plus 4, that's 9x cubed. We bring down everything else. So plus 0x squared plus 3x minus 5. Start the process over. 9x cubed divided by 3x squared gives us 3x. So plus 3x. Multiplying that 3x by the divisor, we get 9x cubed minus 6x squared. We subtract it. First one's cancel. 0 minus a negative 6 is 0 plus 6. Bring down what we didn't use, so plus 3x minus 5. And it looks like we can do this one more time. So 6x squared, leading terms being divided gives us 2. So that's going to be plus 2 for the dividend, for the quotient rather. Multiply the 2 by the divisor, and we get 6x squared minus 4x. This first terms cancel. 3 minus negative 4, that's 3 plus 4, which is 7x. Bring down that 5 that we didn't use. So we know we have to stop right here because this is the remainder is degree 1. It's 7x, x to the first power. That's less than the degree of the divisor, which was degree 2. So writing this in terms of the division algorithm, it's going to be 6x to the 4th plus 5x cubed plus 3x minus 5 divided by 3x squared minus 2x is going to equal the quotient 2x squared plus 3x plus 2 plus the remainder over the original divisor. Okay, so that is our answer. And for the next one here, so I'm just going to get this one set up, and then I'll pause the video, and maybe you guys can try it if you want, and then I'll just have the answer up here. So 2x cubed plus 7x squared plus minus 4x plus 7 divided by x squared plus 2x minus 1. Okay, so I'll just pause it and I'll do it real quick. Okay, so when we divide these, we end up getting a quotient of 2x plus 3, a remainder of negative 8x plus 10, and I wrote it down there at the bottom using the division algorithm. Okay, and then for, I believe this is the last one here, so I'll do something similar. I'll do the setup. It's pretty important for the setup, and then I'll pause it and I'll finish it up. So it's going to be 4x cubed minus 2x squared. It's missing the 0 term, or the x term, so I'm throwing in 0x. So I forgot if I mentioned it, but the reason I throw in the 0 is because everything lines up. All the correct terms, the like terms, are directly in a column. So divided by 2x squared, this is missing the x term, so I'm throwing in a 0x. Okay, so that's pretty important. You can technically do it without doing this way, without putting the 0 in, but I don't recommend it because when you do put it in, everything lines up nicely and it looks the way it should look. Okay, so I'll pause the video and then have the answer. Okay, so we have the final answer here at the bottom. So we got a quotient of 2x minus 1, a remainder of 2x minus 4, and we knew to stop at that remainder because the degree was less than the divisor. So then I wrote that at the bottom using the division algorithm. Okay, so that is it for section 4.7.